Okay, welcome back. I'm looking at our book once again. Just want to refer to some of the pages, some of the concepts in our book. I'm referring to page 1085 in chapter 16 and under linked list as an ADT. So especially for our online students, you probably are noticing there are a lot of pages you have to read, but just want to highlight something here that there are various concepts discussed in this chapter, especially linked list as an unordered linked list. So if you go to page 1097, you will find 1097 shows you unordered linked list. So same concepts which are discussed on page 1085 and onward are kind of repeated. How to insert the first node, how to search the list, how to insert the last node on page 1100. Then it shows you several types of cases. I'll be highlighting some of these cases in our discussion as well. The header file of the unordered linked list is discussed on page 1105. Then it jumps on to 1106. Just want to show you page number 1106. On page 1106, it shows you ordered linked list. So same concepts are repeated again. So if you understand one area of this chapter, you have easier time to transition to ordered linked list. So under ordered linked list, again, it goes back to the same concept, searching the list on page 1108, inserting a node, and there are different cases, the different scenarios for inserting. For example, case 1, case 2, case 3 and 3A on 1110, case 3B on 1111, deleting a node. There are different scenarios for deleting a node as well, page 1113, and then it moves on. Then on page 1117, your book talks about printing a linked list in a reverse order. So instead of going forward, you can go backwards. So same concept, but slightly different way to access the data. So then it shows you few pages of discussion on that one. Then page 1120, it shows you doubly linked list. Doubly linked list, just like we talked about our ordered and unordered linked list. It shows you same kind of concepts if you notice on page 1120 right there. How to initialize it, how to destroy it, how to search it, how to retrieve the data, how to display the data, how to find the length, how to find the front and the back, and all those kind of things. And this is repetition over and over again. At the end of the chapter, it talks about circular linked list. Circular linked list. For our demo, that's the one I'm using. I'm discussing circular linked list in this discussion. One of the method is how to initialize. How to initialize your list. And for initialization, we have a method called destroy list. From this method, I'm calling the destroy list method. So let's look at the destroy list method. And here is our destroy list method. Notice that this method, what do you think, guys? Do you think this method could be an internal method, like a private method? This could be a good candidate for as a private method, because I can simply call initialize from a main function. I would probably never call the destroy method directly. If I want to call the destroy method directly from main, I could, but this could be a good candidate for private data, private method as well. Doesn't take any arguments, doesn't return anything. The main purpose of this method is make sure that each node is destroyed, is deleted. So the memory assigned to each node has been reallocated or given back to the operating system. So to do that, what it does, it creates a couple of pointers. We did create a pointer earlier, like a current pointer. It also creates another pointer called temporary pointer, temp pointer. So we know we have used the current pointer earlier. So let's say our current pointer is here, and we only have two of these nodes. First node actually has a pointer called first. The second node has a pointer called current. So then we check if the first is not null, If the first is not null, it means there is some node, at least there's one node, first is not pointing towards null, then it means my current equals to first link. Then put the current where the second node is. So I can cycle through this one. So I can cycle through, I can go to each node and I can destroy each node. And then first link, make sure it points towards null. Our goal is ultimately point every single link towards null and destroy it. So we did these two things. First we said where we want to place our current pointer. Secondly, where the current pointer is pointing, put a null there. So when we move on to the next one. Then I say in the next while loop, if the current is not equal to null, if it's not equal to null, put a temporary variable where the current is. Put a temporary variable where the current is. So put another temporary variable right there probably, and point where the current is pointing. So I can move my current to the next node. Notice the current equals to current link. So the current pointer moves to the next node. Let's say node number 3 or node number 4. It continues to move in that direction. And delete temp. Now delete means reassign the value or the space assigned to that particular node. Give that space back to the operating system. That's what delete means. If we don't use the delete command, then we are still holding on to the RAM. And imagine if it's a very large data, then we are taking a lot of big chunk of the memory. So delete temp, and then it's going to cycle through at one stage. It will find it is equal to null. It is equal to null. And then it will exit out. And then the first pointer which was initially pointing towards the null, we are saying, okay, we have deleted all the nodes, so we just want to make sure first is also pointing towards null. Otherwise, if we don't do that, first we'll try to find the node actually has been deleted, that might be an issue. So we just want to make sure that first is also pointing towards null, and if we had few of these nodes, just initialize your counter as well. So basically cycles through and deletes all the nodes, and the first pointer is also pointing towards null. So that's your destruction of your linked list. Now, why the destroy is necessary? I have highlighted that one in our discussion, but why you want to destroy the linked list? Why you want to have the option in your code? So let's say you have created a linked list. You want to start fresh. You want to rerun your program the second time. You do not want to go and leave those existing nodes in place, which the memory is being held, and create another list somewhere else. Another list somewhere else. And you just create newer and newer nodes, and you're still holding on to the previous nodes, which you really do not need. Do you see what I'm saying? You're holding on to the memory for absolutely no reason. So as soon as you're done using those nodes, you have done using that linked list, release it back to the operating system. So it's done, it has been released. Then you can create a brand new linked list. Let's say you are testing your program. Now you say, who cares? What if I don't destroy it? When you don't destroy it, if your data is very large, it's called memory leakage. And in fact, have you heard in Java garbage collection, garbage collector? So there is a function, built-in function in Java, which does exactly the same thing. Once you have done using your class, and you want to run a garbage collection program. So it's a memory leakage issue. If I don't release this one, if I have larger data, my program will crash, my system will crash, because all the memory has been taken by the operating system. This was a bigger problem when our RAM was much smaller. And these days, if our programs are much larger, still it could be an issue. So just want to be as a safe developer. I'm going to show you one more method, and that method is called search method. Search method. Then I'll run this program and demo it for you. So this search method you ask the user, what do you want to search? So let's say you have a linked list which has values 16 and 18. That's your linked list. So you want to search something, either it's already exists in the linked list, one of the node is available, or one does not exist. If it does not exist, you'll simply display a message, it does not exist, if there's no match. So you grab the value which you want to search. So user is going to send you that value, and that value is of type. I know it's a redundancy here, but that value could be integer. And because this search method is not designed to change anything, that's why it's a constant method. It's a constant method. You're capturing that value as a reference. It means you're not sending a copy of the value, you're just sending the original value. So that's another discussion we can have. I don't want to confuse you at this stage, but you're sending the original value. Let's say the value is, you're trying to search 18. User types 18. It takes some memory location. That's the same memory location you're sending, not a copy of it, not a duplicate copy. If you don't have this ampersand sign, the program will still work. But this time you're sending a copy of it. But by using ampersand sign, you're just using the original value, original location. Then we create a current pointer here, just like what we did in the past. So just want to have a current pointer so we can probably cycle through this one. We have a Boolean variable called found, which is set to false. This Boolean variable will tell me if the value is located or not located. Then I check if the first is not null. Of course, in our case, we have few nodes in place. So first is not null. So we go inside and we assign the current location. We assign current pointer towards the second node. That's what it means. Current equals to first link. So now current is, and this is the place as a new developer, you want to put a system pause and you want to say, show me the current. So I would recommend highly you come here and do such a thing. And put a system pause here, and I'll show you what I just typed. All right, so I just typed, I want to see the location where first is pointing, and I want to see where the current is pointing. I want to see their values. I want to see their addresses. I want to see where each one of these pointers are pointing. So you can check that way. I'm not displaying the values. I'm not displaying the info. I'm just displaying where each one of these pointers are pointing. So this will indicate the first is pointing towards something, which is the first node. Then we can verify if it's really the first node. And the current will be the following node. And then you put a system pause there just to check and just to verify that information. So this I recommend highly for especially online students. When you're running this program, use a lot of system pause just to see if the results match your own understanding. Then this is the loop which will tell us if the value is found or not. So remember, if you want to visualize it, current is right now pointing towards the second node. First is pointing towards the first node. So I check in my while loop. If the current is not first, which is true in this case, it's not first because current is somewhere else, and the found is not found. Help me understand this one. What was the initial value of found? False. We set it to false, if you remember. So this means not false means true. If this is true and this is true, we have AND operator in between. Both conditions must be true. If they are true, stay in this loop forever. At one stage, one of these conditions will become false. Either the found will become false, found will become true, and this will become false because we are reversing it. Or current and first will become exactly the same because current is going to cycle through. At one stage, it's going to come back where the first is pointing. at one stage. So let's see what happens. It checks if the current info is referring to this info here. This is current info. If this info matches the search criteria is given by the user. That's the value given by the user right here. This info here. This was the argument provided to us, or the value provided by the user. If they match, found equals to true. That value is found. Initially the found was false, so reverse it to true. Else, go to the next node. Go to the next node. And if this info was a match, make this one, and if this is the true condition, and by the way, you can use another if here, but this is another faster way to not to use an if and just get the result. If the current info and the search, they are exactly equal, then the value will be Boolean true. The Boolean true will be assigned to found. If the found is true, then your condition will become false, and you will exit. And you will exit. And you simply say return found, which means return true. So true will be returned. If none of these things happen and nothing will be matched, then you cycle through all of them and you do not meet the criteria, the false will be returned to the found variable. And false will be returned as a return type. And it will say nothing was found. All right, let's test it out. So let's test it out in our main function. So I go to the main function. I'm going to expand this main function. And before I run this one, let me just very quickly show you a couple of things here. So I'm creating two lists, list 1 and list 2. And what type of data I'm creating? Remember, in our template, we called it type. Here, I can declare what type of data I want. What is your assignment, by the way, for assignment 1? You want to create strings as well as characters. So just want to give you a tip here, clue here, something you need to do here. You need to ask what type of data you want to create from the user. User will tell you, I would like to deal with strings, such as first names or name of the city or something like that. Or you can actually, user can tell you, I would like to deal with characters. So that will change here. Change here. Then I have some kind of local variable to ask the user, please enter your data. And you can exit by typing -999. You can have your own criteria. It doesn't have to be this criteria. So user will provide the first value. Let's say user provides you 16. So 16 will be added. It says, is 16 equal to, not equal to 999? If it's not, stay in this loop forever. At one stage, user will type -999 or some other value. You can actually have a terminator, the terminator you want. And every time the value is captured from the user, it will be sent to insert node. We'll talk about insert node in our next lecture. But once the value has been inserted, you ask the user, do you want to add more values? Give me the new value. If the new value does not match -999, stay in this loop. And you go through this one few times. Then at the end, you say, okay, I want to see the results. I want to see the results, and you see the results right here. You say, here's my list 1, and I'm going to call the print function. And we went through the print function. Print function basically cycles through all of the nodes and displays all the values of each one of those nodes. And then you want to check the length of your linked list, and we call the length function. You want to search something, enter the number to be searched. User will say, yes, I want to search specific value. Then you grab that value and you call the search method. When you call the search method, here's the argument you're passing. You pass that argument right here. So user provides you this value, whatever the value is, and you send it to the search method. Search method verifies, returns you either true or false. Remember, we had a found variable. It returns you true or false based on what value was returned. If this was true, if this answer was true, then we'll say value is found. If the value was false, returned as a false, then you'll say not in the list. Let's run this one, then we'll talk about a few other things. So when I run this one, and you can probably see over here, I'm running the program. It's asking enter number ending with -999. So let me add some data here. My data is 16, 18, 5, -2, -999. Here's my data. So I'm hoping this will be my terminator. This will end my list. So I added 4 nodes, 16, 18, 5, and -2. In our unordered linked list, that's how the data will be added, 16, 18, 5, -2. In our ordered linked list, data will be ascending order, or you can make it descending order. Let's see what kind of data do we have in this case. So when I hit enter, and here it is, I have -2, 5, 16, 18. So my circular linked list was ordered circular linked list, which means as soon as I capture the data, it looks at the existing values and places inserts appropriately. So that makes our program a little bit more efficient, especially if you are reading large amount of data. And it tells me the length, tells me there are 4 nodes there. I needed to know that information so I can actually maybe cycle through, or maybe whatever purpose is, how many records are there. And it's asking, what do you want to search? I want to search 16. So I enter 16. And we just verified. Remember, I put a system pause there. I had first I was displaying. This is what I was showing you when I was in that program. I was showing you the first. This is the current. These are the pointers. They are not pointing at the same location. This address is 8A0, AD0. So the first is pointing on a different node, towards different node. Current is pointing towards different node. Just wanted to highlight that one when you're going through these steps. All right, hit enter, and it says 16 is found in the list. Because if we call the search method basically went through the list and says, do you have that value? And we discussed that search method, and it returned that true back to us. And then we'll talk about delete and some of the other methods later on. Okay, I'm going to pause here.